Sorry, due to
Sorry,
some
due
wait a minute. Sorry, due to some technical error, I had to leave. My slides were not moving. So let me reshare my slides and start from where we had stopped. So I guess it will work now. The point where we were discussing ion exchange. So I had asked you a question like what is why do we require ion exchange? So basic aim for ion exchange is to remove hardness, and hardness is contributed by the presence of calcium, magnesium, and few other cations in water, right? So basically it is because of these two. Now to remove, like if the water is so hard, and if we remove or if we want to reduce the hardness, what we can do, um, we can use ion exchange resins, right? So in case ion exchange resins are of this sort, so it will react with calcium or magnesium to form R2Ca, because here the valency is 2, so we require R2. So similar reaction might follow, and in case if we want to regenerate, we can reverse the reaction because it is a reversible reaction by adding NaCl to reform this, right? So this is the regeneration step. So this is the reaction which we follow to remove the hardness which is present in that water. Next step is the RO. Now RO or the reverse osmosis, this is one of the most common treatment step. Even your households, they have reverse osmosis which is present in your water purifiers. So this is nothing but a sort of membrane which is used. Now these membranes are nothing but they are filters, and these filters they have pore size. So in case of RO, now these membranes can have varying pore sizes, and depending on that these membranes can be divided into microfiltration, ultrafiltration, nanofiltration and reverse osmosis, where we are utilizing, like these membranes are divided based on the size of particles it can separate. So here we can separate as small as very few nanometers, or even the smallest. Only sodium and lithium are the smallest uh, ions which might or which is having lesser efficiency using RO. Other than that, all the ions we can separate using RO, right? All cations, microbes, anions, and other organics, etc. Everything we can remove. Next is if we talk about disinfection, then microbes they are present in water, and here we need to disinfect it by various methods. So these methods include UV treatment, ozonation, chlorination. Okay, so if we talk about recent times, then for our case, what we receive in tap, like the tap water we receive, it is disinfected by chlorination process. Okay, so tap water usually has high content of chlorine if you measure. Next is for groundwater purification. Mainly, our target will be to remove the hardness and pathogens. So, why hardness? Because hardness, if we talk about groundwater, then there are various nutrients which are dissolved in soil, and since groundwater is like below this soil, so there are chances that water, if it comes in contact with soil, there are nutrients which leach out, and water, like there are more nutrients leaching out from the soil, and groundwater having more hardness and more uh, soluble, like TDS will be more, conductivity will be more in that case. Further, pathogens will be more, so mainly we need to have disinfection and ion exchange, which are the major process, or we can have even lime soda process for hardness removal uh, to purify groundwaters. Now let's talk about the wastewater which is generated, uh, and like this was all about purification of water which is uh, required for you know uh, uh, for groundwater and surface water, where our direct application is to have uh, uh, you know uh, drinking purpose. But in case if we generate wastewaters from our households and industries, then the wastewater which is generated, that requires a complete different treatment procedure. So here wastewater treatment can be divided into four categories. First is the on-site disposal. Now, on-site disposal is for the residential area which is having which is remote and there is no nearby waste collection system. So here, the on-site disposal means you have a discharge line which which is connected to an inside or underground septic tank. So this image is of septic tank, where this is the inlet and these two are the baffles. So by providing baffles, what we are doing, we are reducing the flow, like flow rate, and by that we are allowing the solids or the particulates or the suspended solids to reduce their velocity to fall down, and sludge will be formed at the bottom, while further treated water will pass, and there could be some filter provided and it will again pass. Now, this water, outlet water, will be passed through the underground rocks and soil, which might further act for the uh, oxidation or degradation of the organics, right? And further, we can have treated water, which will end up in as groundwater, or uh, like it will end up as groundwater, right? Yeah. So now next main points that we need to discuss is domestic or sewage treatment plant, industrial treatment plants, and common effluent treatment plants. So now, why do we need separate treatment plants? Because mainly if we talk about domestic treatment plants, the water will have completely different characteristics as compared to the industries. So, sorry. So the major components which are present in domestic will be organics and suspended solids. If we talk about industry, so depending on application, there will be a variable load of organics. There could be some variable load of COD also. Now, majority of the organics which are coming out from domestic water, these organics are biodegradable. Because if we talk about the organics, then it could be because of the toilet waste waters, then it could be because of the food which we are disposing. So all like from all that, whatever the water is generated, that is biodegradable, or the organics, they are biodegradable, more or less they are biodegradable. uh, Nowadays, again, if we see, then let's say if we wash the vegetables, then these vegetables might be coated with insecticides and pesticides, and they end up into water through which we wash. And such water, if we treat, then pesticides and insecticides are difficult to treat, but we are like comparatively they are less, and more BOD is there, is much more great higher. Like, sorry, we cannot write this way. uh, we can say BOD, like majorly the organics are biodegradable, so we can use biodegradable, for biodegradable ones we can use some microorganism treatment for their degradation. While in case of industries, there are chances that some more toxic recalcitrant pollutants are present, and also there are chances of heavy metals being present. There are chances that some pharmaceutical drugs being present. Okay, so all these metals, they require some specific treatment. For if we talk about pharmaceutical drugs, they are not biodegradable. So in that case, these drugs might require some special treatment. So now all these we need to discuss one by one, and what some special treatment we provide in case if we have pharmaceutical or different difficult to degrade organics. So all such special treatments we will discuss from now. So let's talk about these one by one. um, so steps for domestic and industrial wastewater. So generally, if we talk about steps, then preliminary and primary steps are followed in both, and they are one of the most common. But later, tertiary treatment and so on, they depend on the specific nature of wastewater. So sewage treatment, tertiary, usually requires disinfection, while some special treatment which are required for, say for example, removal of pharmaceuticals, then these come into tertiary treatment, which are nothing but special treatments required. Special treatment for a specific application and pollutant. While if we talk about all these are very generic, and you can generalize it for both domestic and industrial. So if we talk about preliminary method is nothing but just in screening through grit and bars, bar racks. So here what we are doing, screening or strainers we employ, which results into removal of some very large or big materials which are present in water. So those are removed through preliminary method. Next comes this primary, where we employ so preliminary here screens, bar racks. Then if we talk about primary, then it uses coagulation, flocculation, and followed by sedimentation, because Like, why do we need a sedimentation process at the end of coagulation flocculation? Because whatever the sludge is generated, we will allow it to settle. So whatever the settling process occurs, it occurs in sedimentation. Then secondary process, it allows the organics to be removed which are biodegradable in nature, which are biodegradable. So here we allow the biodegradable organics to be removed. Okay, so both industries and domestic sewage, they have biodegradable organics. So for that we use secondary process. So there could be multiple types of process in that also, we will discuss in detail, right? And next is tertiary treatment. So tertiary treatment is nothing but any specific process we apply for our purpose. So these tertiary treatment could be adsorption process, advanced oxidation process, photocatalytic degradation. So all such process, Fenton process. So I'm just giving you the names right now, but if you want to know, we can, like, later in all the classes we will discuss each of these process one by one. So now further, if we categorize, then preliminary and primary treatment, they are nothing but physicochemical processes. So preliminary and primary treatment, they are nothing but physicochemical processes, because basically we are targeting the physical properties of water, and further by adding chemicals, uh, physical and chemical properties of the water in the form of suspended particles and in the form of some soluble material by adding chemicals. So it is nothing but known as physicochemical treatment, which involves mainly preliminary and primary treatment. Next comes is biological treatment, where we are using microorganisms for treatment. So that is nothing but biological process, and if we club those, then physiochemical and biological treatment, if we apply both, then it is nothing but physiochemical and biological process. So is it clear so far? I hope it is clear. So this is what we have discussed. Municipal treatment, where or municipal or domestic sewage treatment, where we apply first the primary treatment to remove coarse and fine particles by providing coagulation and flocculation. Then we provide BOD removal through secondary process, where we provide microorganisms to act. And what we are doing, we are converting BOD, which is nothing but any organic which is present, to convert it into or CH4. So this will be in the presence of oxygen, in the absence of oxygen. Right, so in the presence or absence of oxygen, we are converting this organic into either CO2, or in the absence of oxygen as CH4. Yeah. So next comes is the tertiary, where we can use activated carbon. Now activated carbon is one of the most common adsorbent which is used in industries. Now can you tell me what is an adsorbent, and where we can use, what type of impurities it can separate, what are like what all you know about adsorbent, can you tell me? Okay, so adsorbent is or adsorption is a physical phenomenon where we are utilizing the surface forces, right? So whatever the pollutant is present through some surface, say for example, this is the pollutant, so and this is the surface of adsorbent which has some active sites. Now these active sites has some sort of attraction with these pollutants. Now these force of attraction could be some physical force like van der Waals force and some chemical force in the form of covalent coordinate bond formation and so on. So this I have already told you. So similar phenomenon we can use for water treatment also, where activated carbon is one of the most common adsorbent, and that can absorb variety of pollutants, including odor, organics, uh, then dyes are also organics. So basically these all can be easily removed or absorbed on the activated carbon such that it can be removed from water. Now next, if we talk about industrial wastewater treatment, so if we talk about industries, then there could be some two type of industries. The one which treats on its own. So for example, bigger industries, like if you take example of Reliance, then has a huge plant, and whatever the wastewater is generated, it will have some inbuilt or not inbuilt, but it will have some on-site treatment, or in the campus itself, in its industry itself, there will be some plant which will be taking care of wastewater treatment, right? So such industries, if they have effluent treatment, so in its campus itself, then you tell it, like if the industry treats it or treats wastewater on its own, then such treatment plant is known as effluent treatment plant, which is particularly for wastewater treatment. So effluent treatment plant. Now there are industries, say for example small scale industries. Now these small scale industries, they generate wastewater, but due to lesser uh, um, lesser amount of money available, or more uh, cost involved in wastewater treatment for such a small amount of water, because small scale industries usually generate a comparatively lesser amount of water, so it might be costlier to treat water if it's just that industry, particular industry. So what uh, people does, if there are multiple small scale industries housed in a particular region, say for example all these are industries, so water streams that are coming out of these industries, they are collected. Maybe some preliminary treatment might be provided, but or not, whatever it is, after preliminary treatment, this wastewater, it is collected, it goes to a common place which is known as CETP, which is Common Effluent Treatment Plant. So name itself suggests it is an effluent treatment plant, or what wastewater effluent treatment plant, which is common for all the industries which are housed in a particular region. So whatever the wastewater is coming from that region, that entire wastewater volume will be treated, right? So that is nothing but known as CTP. So CTPs are nothing but used for uh, wastewater treatment if we have small scale industries. Um, Clear till now. Yeah, so now let's discuss each of the process one by one, and how each of these processes work in case if we apply it for uh, industry or municipal treatment, whatever, wherever we apply, you will get to know what pollutants it will remove, so you can even further classify on your own, like whether this process is required, like where it is required and where I can apply. You can simply apply your mind as well once you know what is going on in this in that process. So first is we have listed down what treatment procedures we follow in case of industry and domestic wastewater treatment, which are nothing but these: preliminary, primary, secondary, and tertiary. Now, in case if we start with primary treatment, so primary treatment majorly involves removal of some bigger or coarse or some small even suspended particles, etc. So these, like all these we are targeting. So first and foremost, if we have some coarse material which is present, so for that we can use either bar racks, grid chambers. So this figure shows you these are nothing but bar racks. So these bar racks you see here, these are providing obstacle to bigger particles. So, okay, so this is the opening inside, and whatever the material is bigger than the opening, see here, and they are collected here, right? So they will get collected, and this is how you can like basically you are providing a bigger chimney, because water which you treat in common effluent treatment plant or domestic plant or even industries, these treat millions of liters per day. Okay, so millions of liter means lakhs of liter, like 10 lakhs of liter per day you treat. So for that volume, you need a bigger screen, and that is why you are providing a bigger screen in the form of bar racks, right? And further, there could be some grid chamber where you can remove some small materials, like for example, sand, dust, and some smaller materials you can easily remove in that grid chamber. Just a minute. Give me a minute. Till that time, can you uh, say if it is clear to you or not? Yeah. So next once the water from water once coarse particles, coarse materials which are present in water, they are removed, we send it to equalization tank. Now what equalization tank does, and why do we need it? Okay, so if we talk about a particular industry, so ETP or CTP, let's take example of this. So there are chances that the amount of wastewater which is generated might vary, because uh, in case of small scale industries, so they operate on batch process. Okay, so operate in batch mode, and depending on the requirement, their batches they change, right? So in that case, there are chances that the wastewater generated it changes, the flow rate changes, pollutant load changes. Right, so in that case, if we send wastewater which is having variable flow rate, variable um, uh, pollutant, then it, for example, I have already designed a plant and it is already running. Okay, so it will be able to treat only a particular amount of pollutant load, only a particular amount of flow rate. Now, let's take an example that I am staying in a house which where we live four people. So I can accommodate one more person if someone comes suddenly and I have to offer some food suddenly. So I can accommodate maximum one person at a time in case if I have four people housed. Okay. Now, so in case suddenly if more number of people come, I will not be ready for that. So in similarly, the design in equipments that are used in industries, they are designed such that it will be able to treat a particular flow rate and it will be able to treat a particular pollutant load. Now, in cases where the amount of flow rate or the amount of water coming as flow rate, it changes, amount of pollutant concentration changes, the efficiency of process changes and subsequent equipment are also suffered, and the effluent which is discharged or disposed in environment, the characteristics, it will change, right? So to minimize this, we have an equalization tank where all the feed streams of water, whatever they are coming, we provide slow agitation, and by providing slow agitation, what we are doing, we are just mixing all the types of wastewater which is coming, so that the pH, the pollutant concentration and the flow rate, they all are uniformly maintained, and that water, once it is its concentration and load, they are uniform, so at a particular flow rate only it comes out of that equalization tank and it goes further, so that there is no sudden shock on any instrument, right? Is it clear till now? Yeah. So next equipment which we should talk about is the sedimentation tank, where sedimentation means we are allowing the particles of bigger size to fall under gravity. Okay, so under gravity, the bigger particles settle. Okay, so if I give you a common example, what we do, for example, if you have uh, sand which is mixed, or dust which is mixed in water, if you give some time, then the dust will settle, right? So that is nothing because of the gravity, the particles, because of their density difference, they are settling. So I have switched off here. So here what we are doing, we are allowing those particles to settle. Now this settling can be of different type. Let's discuss each one of them. So one is discrete settling. So discrete settling means if the particles are so separate and the concentration is separate, then the terminal velocity or the terminal settling velocities, they are maintained throughout, and it will uh, you know they will constantly fall or constantly settle at that particular settling velocity. Now next is if somewhat more concentration of particles, or in case you have added some coagulant or flocculant, then there are chances that bigger aggregates are formed, and these aggregates, due to some interaction, they form bigger particles, and settling at an increased rate, settling happens. Okay, so now next is, if we keep on, like, there are chances that if we move downwards in a settling column, then more and more particles that have settled, they will be there. Okay, so they are settling, and at the lower portion, more particles, or in case there are more particles, hindered settling will occur. And this hindered settling is settling occurs because, for example, if one particle, they provide obstruction for settling, so the overall uh, settling velocity reduces, right? So here uh, you can say one particle is hindering the settling of another particle by reducing, by colliding it, so it will reduce its velocity for settling, and that is why nothing but it is known as hindered settling. And type 4 is nothing but compaction settling, where whatever the settled particles are there, further, like, there is no space. Okay, so further whatever the settling will occur, the particle will add, and they will compress the particle which are already present, and water might move out. So above that there will be purified water. So all these types of settling zones are there, which through which each of the particles which undergo settling, it goes through. Now for settling to occur, we can provide a specific instrument or equipment which are there in the industries for a proper settling. uh, Now there could be the some Hopper settler. uh, Let me show you the example. Okay, of this type, there could be of this type. So all this lowering, and here you provide some minor agitation. Okay, so by providing minor agitation, you ensure that uh, uh, there is somewhat mixing, but not so rapid mixing, so that the particles, they are destabilized, and they do not come closer, and they do not interact to form bigger particles. And next is, if we want to separate suspended particles, one more method you can use is dissolved air flotation. So for that, what you are doing, let's say this is the inlet of water, and this is a tube which might you have provided. So through this you provide, there are holes, and through this you provide air, right? And air could be N2 or pure air, anything you can provide. Now as water comes in, the air which is there, so air bubbles at high pressure, if you are passing air from this point, it will come out as bubbles, and these bubbles, they take particles which are having lighter density. So here you separate particles of lighter or smaller density, so lighter particles or smaller density particles. Yeah, so those particles will be taken up by these air bubbles, and what happens is air bubble will collapse, and the particles, it will come on the top surface by with the help of air. Now you can use some scrapers and you can take off this particles from the upper surface, and later this is how you separate the particles through dissolved air flotation. So this is all about dissolved air flotation. So is there any doubt so far? Okay, if not, let's move forward. Next class, it talks about like this class was about the treatment of water through primary treatment, where we are removing some suspended solids, we are removing some coarse material through basically gravitational force or through some screens or by uh, flotation method, dissolved air flotation, which removes lighter density material. Now in case if you have organics which are dissolved and some more suspended solids which are much more finer, then what you do, so these organics which are basically comprised of carbon, hydrogen and oxygen, they are converted to carbon dioxide in the presence of oxygen, or they are converted to CH4 for example in the absence of oxygen. Okay, so the here you do not provide anything, but for that you require microorganisms. Now these microorganisms could be bacteria, fungi, anything, and the microorganisms here where which requires oxygen for process and which does not require oxygen, they both microorganisms are totally different because their action mechanism are different, right? So the one where we apply oxygen or oxidation occurs in the presence of oxygen is nothing but aerobic process, presence of oxygen. An anaerobic process is nothing but it occurs in the absence of oxygen. Okay, so these two are nothing but basic difference between if we are doing in the presence of oxygen or if we doing in the absence of oxygen. Now there could be some you know, various, you can provide various reactors, or you need to provide various ponds, uh, and these are very big ponds which are provided in the form of lagoons, aerobic digestion, activated sludge process, anaerobic digestion, upflow such upflow sludge, anaerobic process, biofilters, membrane bioreactors. So all these type of processes are used where microorganisms, they act upon the organics and they convert them into some non-toxic form, for example carbon dioxide and water. And so let's see how these process works. So for example, these microorganisms that you provide, you might attach, so they can be provided to any process in two forms. For example, here there are some materials, you allow the microorganisms to stick on these materials. Let's say you provide some stones, granules, so you stick the microorganisms over it. Now as the water passes through this, so water and microorganisms, they come in contact, and uh, the degradation of organics occur. So such process is known as attached growth process, where what happens is the microorganisms which are present here, when it comes in contact with water, so these organics which are degraded, So these organics, they are taken up by microorganisms as their food. So microorganisms take up organics or degrade organics. They take up organics as their food and they multiply in number. Okay, so you at the end of the process, some of the microorganisms die, some of them get multiplied, so you might have more concentration of microorganisms and at the end they die. Okay, so and the organics which is present, they at the end they degrade into either carbon dioxide or methane. And there could be some suspended growth where for example this is the tank, uh, microorganisms, they are present randomly at each point in throughout the tank. So that is nothing but microorganisms are suspended throughout, while in the case of attached, they are sticked on some substrate which could be some granules or some filters, etc. So now once we have known what type of arrangement uh, are provided for bacteria to grow or for degradation based on suspended and attached. Let's see first suspended, because which is one of the most common. Let's see lagoons. Now lagoons, you can have degradation of organics where you do not, you might or might not provide external aeration. Okay, so you might or might not provide external aeration. So let's see how lagoon works, and where we have not provided any external aeration, or external aeration means you have not provided uh, any extra source of oxygen. So let's see, this is the water surface, and obviously there will be some oxygen which is there in the atmosphere. Now because of the equilibrium and some solubility of oxygen, there will be oxygen which is present already in the atmosphere, in the water, and there will be some more oxygen which might get dissolved from the air, right? So there will be transfer of oxygen with, between water and air. Now this oxygen is taken up by bacteria, okay, and bacteria might form some dead cells or some new cells by consumption or degradation of the organics to form carbon dioxide and even phosphate, like such, mainly for organics. And for ammonia you can also have changes. Just a second. Yeah, and now this carbon dioxide, so this is a kind of cyclic process. Okay, so this carbon dioxide, it is taken by algae which is present. So those algae, they take up carbon dioxide and they multiply and further release oxygen. Okay, so the role of algae here is nothing but it uh, consumes the carbon dioxide formed by the degradation of organics. They release organics which is further used up by bacteria to degrade further more organics which is coming in through wastewater. So that cyclic process of continuously you know generation of carbon dioxide through degradation and further generation of oxygen by algae by taking up that carbon dioxide, it continuously goes on. But as we go deeper into the pond or lagoon, at lower portions, there are chances that uh, sludge are deposited, and also the oxygen concentration reduces here. So if in this sludge, if there is any organic left, what we can do, we can provide the microbes here which are specific for anaerobic digestion, So they degrade the organics to form CH4 through anaerobic digestion. Right? So multiple processes occur on its own where human intervention is very less required here. You just need to have a frequent or timely uh, cleaning, timely removal of sludge, and so on, so that you can maintain the efficiency of such lagoons. Now, one of the most important aerobic process which is used is activated sludge process, where you uh, are providing continuously in a tank. You provide, for example, air through some diffusers. So through this air will be provided, and this air, like oxygen, will be taken up by bacteria and microorganisms. They degrade uh, the organics, and further they go to a sedimentation tank where the sludge in the form of microorganisms and microorganisms, they somewhat is disposed and somewhat is recycled back. Okay, so it is a kind of complete process where treatment and recycling of microbes, they take simultaneously. Yeah, so next is anaerobic process, where it is a closed chamber. So anaerobic process is a closed chamber, and at the upper portion here, let's say there is some inlet source, and this inlet source is acted upon. So let's say there is water, so it is acted upon by microorganisms, and since there is no oxygen, it will yield into CH4. Now this CH4, here the gas gets collected, so CH4, and which is nothing but, it is a sort of biogas. So which means you can use this CH4 later to generate energy. So here you are generating biogas as byproduct. Okay, so such anaerobic digestion, they also takes care of high amount of POD and COD if they are present, while activated sludge processes are kind of sensitive to uh, higher amount of PODs if they are present. Then further there could be filters which can be packed bed filter, fluidized bed filter, trickling filter, rotating bed filter. So where it is nothing but attached growth method is used, and here what you are doing, you are attaching the microorganisms, the water flows through it, and the degradation of organics occur, right? So uh, it is the example of attached growth. But if we look into the industrial scenario, activated sludge process is the widely used process. Okay, yeah, so I guess it was that's it for the brief, or that's it for the lectures that were covered. Now let's take a look, let's take a look at the assignment, or the sample assignment. So is it clear so far to you all? Yeah, so let's start further. So dash are the smaller size particles, while dash are the larger size particles. So here the size ranges are given. So smaller size particles are nothing but colloids, uh, which has usually this size range, while flocks are nothing but having bigger size, which are formed by aggregation or more colloids coming into contact to form bigger particles, which are usually known as flocks. So correct answer here is nothing but colloids and flocks. Next question is identify the figures. Now, if we look into the figure A, then these are nothing but turbine agitators, while next are nothing but propellers, and the C is nothing but pedal mixers. So each of these has different role, and now if you look into the role, so depending on the shape that it has, it will serve different purpose. For example, turbine agitator, they have such a shape that the mix input is axial, while the mixing and output is in radial form. While pedal agitators are nothing but they have blades uniformly distributed across the reactor or throughout the reactor, so that and also near the wall, so that agitation is complete. While here you just have, in case of propellers, you just have axial mixing. So here the correct answer is A is turbine reactor, B is propeller, and C is pedal. Okay, so now let's look into the next question, which is nothing but we talk the following process is used in tertiary treatment of wastewater. So tertiary treatment are nothing but any advanced treatment which is not common to a particular, not common to all. It is a specific process. It could be, if we look into the options, then activated sludge process is a secondary process, and these two are nothing but tertiary process. So membrane process and ozonation depend. Ozonation is a kind of process which is used for disinfection, and the membrane is used for uh, separation of ions and some uh, um, organics and heavy metals from water. So these two are tertiary methods, which is nothing. So the answer here is both A and B. Now, the treatment plant where effluents of a whole industrial cluster is treated centrally is known as dash. So, it is nothing but common effluent treatment plant, because I have mentioned just few minutes back in the class where if you have a cluster of industries in an industrial zone, then these small scale industries, there are chances that they might not be able to treat the water because of financial reasons or some space crunch or some different issues. So that is why there is a common zone where wastewater from all the small scale industries from a particular industrial sector is collected and it is treated, which is nothing but known as common effluent treatment plant. Just a second. Yeah. So next question is about biological treatment, that is purification of wastewater, primarily by decomposition of suspended and dissolved oxygen matter by microbial action, is nothing but known as secondary treatment. Okay, so just now we have discussed that by secondary process we use microorganisms to degrade or decompose the suspended and dissolved oxygen or dissolved organic, which is like mainly dissolved organic matter. Next is match the type of settlings with their appropriate descriptions. So first one is discrete settling. So discrete settling is where all the particles they fall at their individual settling rates, and these rates are never hampered or changed in the presence of other particles. So for that, if you look into the options, it is 2, where all the particles settling are they fall with their individual settling velocities same throughout their entire fall, right? So for P it is 2. Next is hindered settling, where if the velocity, as the name suggests, it reduces, right? So settling at a reduced speed due to the interaction with neighboring particles, which is option 3, right? So let me just do it. For P it is 2, Q it is 3, and yeah, only one left, but still let's read it. Flocculent settling, where settling velocity increases due to collisions of other particles, right? Because here bigger particles are formed, which causes uh, uh, particle terminal settling velocity uh, to increase. Yeah, so option is P2, Q3, and R1. Next question is tube settler increases the settling capacity of sedimentation tank by dash. So here tube settler means we are reducing the vertical distance. So as we reduce the vertical distance, so the amount of distance or the vertical distance any particle has to travel, it reduces, and hence the settling can be faster. Okay, so here the option is C, which is the correct answer. Next question is for a continuous flow settling tank 3-meter deep and 55-meter long. So let's draw that. So, sorry. Here you have a tank which is 3-meter deep and it is having 55-meter length. Now, what could be the flow velocity of water for effective removal of 0.03 mm particles? So, here the particle diameter given to you is 0.03 mm. Specific gravity of particle is rho p, which is given to you as 2.65, and viscosity to you is given as mu is 0.01 centimeter square per second. Now if you look into the options, it is centimeter per second, so let's convert everything in centimeter. So this would be mm, 1 mm is 0.1 centimeter, so that this would be 0.003 centimeter. Okay, now let's understand the question. So here let's say a particle is coming from this point. It wants to settle and it has to travel vertically 3-meter distance, and lengthwise it has 55 meters distance to travel. Now this is Vt, this is V, let's say this is V. So V, okay, so here it is Vs given. So let's say this is Vs. So depending on the Vs and V, it will settle somewhat here, right? Okay, so before it goes out, it should settle. So there will be some resultant component, and we have a relation between terminal settling velocity and horizontal velocity. So from this data which we have, we can find the terminal settling velocity, and later we can correlate it to horizontal velocity. So let's first find out the terminal settling velocity. and later we can apply the derivation, like from where we have derived that the time required for horizontal distance to travel and the vertical distance to travel should be same, and that is where we can equate the velocities and find out the uh, velocity, right? So let's first find out settling velocity. Now Vs is nothing but g into rho p minus rho into dp square divided by 18 mu. Now g here is 9.181 meter square per second. Sorry, it's meter per second square. Sorry. Yeah, so convert this 9.81 into centimeter, which will give you 98.1 centimeter per second square. Yeah, I hope all of you are following. Now rho p is given to you as 6.2.65 specific gravity. Now specific gravity means it is rho p by rho w. Now if any basis is not given, you always take as rho w, which is the reference. Okay, so here it is normalized with reference to uh, some reference density. So rho p will be, if rho w is 1000, so 2650. So 2650 minus 1000, which is density of fluid, which is water, divided by 18 into mu, which is 0.01, into dp square. Now dp in centimeter is 0.003 square. Do the calculation. It is coming as 8.09. Okay, so now if we equate the times required for horizontal movement and vertical movement before it settles, so till this point the vertical distance traveled and time taken for vertical distance travel and horizontal distance travel should be same. So if we equate those two times, then vertical distance travel will be distance traveled, v equals to d by t. So time equals to d by v. Okay, so now let's equate both the times required. So in case of horizontal distance, time required will be dl, which is the length, distance traveled length in the form of length, per unit velocity, which is horizontal velocity, divided equals to the distance traveled in vertical is d, let's say, so it is depth, so dd, divided by uh, vertical velocity is 8.09. So now cross multiply and find out the final value, put up all the values. So length is 55 meters divided by depth is 3. I guess I have made some mistake in calculation. Let me see. Just give me a moment. Okay, so here we had got settling velocity at 8.09. What we made the mistake was 3 by the terminal settling velocity equals to 55 length divided by horizontal velocity. Okay, so 3 by 8.09 into 55, sorry, VL will be 55 into 8.09 by 3. Yeah, so that is 148.31 centimeter per second, and that will be 1.48 meter per second. Uh, Let me just check the answer. I guess it has to be in meter per second. Just give me a moment, I can verify the answer. Yeah, week 6. I know. So here, what mistake we have made is this 2.65 we converted into kg per meter cube, which was our mistake. So it will remain as 2.65 only, not 2650. So Vs is nothing but uh, sorry, this is wrong. Sorry for that. It will be 98.1 into rupees 2.65, because this is in gram per cc, minus 1 gram per cc, sorry, for water, into 0.003 square divided by 18 mu, which will give you 0.0809 centimeter per second. And in case if you uh, want to find out horizontal velocity, then it will be here 0.089. So it will give you 1.485 centimeter per second. I hope you are clear with this. Now, next question comes is a circular sedimentation tank fitted with mechanical sludge removal unit is to treat 4.5 million liters of water per day. So here you are given flow rate as 4.5 million liters per day, which is 4.5 10 to the power 6, because 1 million is 10 to the power 6 liters in one day, right, which has a detention time theta equals to 6 hours. Okay, now if the depth of tank is restricted to 3 meters, calculate the diameter of tank, and the capacity of tank volume is given to you as d square 0.11 plus 0.75 785H, where H is the depth and D is the diameter. You need to calculate diameter. So how will you do this? From these two data, how are they related? Right? So volume is flow rate is nothing but volume per unit time, or here the retention time. So volume of the tank is nothing but equal to flow rate Q into T, right? So flow rate you are given as 4.5 10 to the power 6 liters per day. So now to find out volume, this time has also to be in days. So 6 hours. Now if you convert it into days, so it will be 24 hours. So one day has 24 hours. So 6 hours will be how many days? So you need to divide 6 by 24 and that you will do. So 6 by 24. Now if you solve this, what you will have is the volume of tank in liters, 4.5 into 10 to the power 6 into 6 divided by 24, which is 1125,000 liters. Now if you convert it into meter, because here you see the height you have is in meter, or sorry, the depth is in meter and the diameter also you need in meter. So let's convert this into meter. Now 1 liter is equals to 10 to the power minus 3 meter cube. So divide this by 1000, you will get the value of volume in meter cube, which will be 1125 meter cube. Now put up this value of volume here. 1125 equals to d square you don't know, and 0.11 plus 0.785 into h is here given to you as 3. So now if you solve this, d square will turn out to be uh, 0.785 into 3 plus 0.11. Okay, it will be 2.465. 112 by 25 by 2.465. It is d square is 456.39 meter square, and d will be under root 456.39, which will be 21.36 meters. Right, so correct answer is 21.36 meters. I hope it is clear. And the last question here is which of the following lagoon system has high operation and maintenance cost? So the answer for that is uh, aerated aerobic process. Why? Because for aeration you need to provide special equipments and diffusers which will provide aeration into the tank. So aerated aerobic process requires high operation and maintenance cost. So that's it from my side today. If you have any doubt, you can tell me, otherwise I can end this meeting. Okay, so if not, thank you everyone for joining. I will end this meeting here.